Alright, hello. In this video we're going to be going over information, getting ready for the Chapter 9 test. As always, I strongly encourage you to pause the video, try the questions on the screen before going over the solutions. So there's a lot of vocab in this Chapter 9 here, so if you want to try just looking through these and then pause the video once you've done thinking about it. Okay, so there's roughly two categories of sequences of series here: arithmetic, are add subtract patterns, and geometric are multiply or divide patterns. Okay, so that's our first definition. Difference between a series and a sequence is a sequence is just a pattern of numbers. Series means add up the numbers in the pattern. Okay, so if you're trying to add them all up, that would be a series. That's the main difference. They're very, very similar, but you add them all up if it's a series. Okay, so finite, infinite. Finite just means the pattern ends. Infinite means it goes on forever. They usually use a ... when they're listing it out, typically. But just because it has a ... doesn't mean it's infinite. Sometimes we'll have a ... and then it says it goes on for 10 terms. That still would be finite because it ends after 10 terms. Okay, and our last one here, converging or diverging. Converging, the terms get closer to 0. Diverging, the terms get bigger or farther from 0, however you want to think of that. And the main thing there is the diverging ones don't have a sum. If the terms get bigger and bigger, the sum just gets infinitely big. So an infinite one only will have a sum if it's geometric and converging. Okay, more practice with vocab. Just identify these, based on the directions here. Identify them and then give an example of infinite geometric series that is converging. Would be an example one that would have a sum. Okay, so I'm just going to go through here. Hopefully you tried these first. So this one is timesing by 2. So that means it's geometric and it's just a sequence because it's not asking us to add them together. And this would be an example of diverging because they're getting bigger. All right, next one is we're going up 6, add 6. So that's an example of arithmetic. It is a series because we're trying to add them up with the pluses between them. And this one would be a finite. Even though it has a ... it ends at 406, so it would be finite. Okay, so an example of infinite geometric. So geometric is just a multiply or divide, and series means add them up. So if we started with like 2 and went times 3 or something, and we're adding those up, all right, that would be, that would be diverging. So converging has to be getting smaller. So maybe if we actually just straight up reverse that, if we went 18 plus 6 plus 2 plus 2/3, we're just dividing by 3 or timesing by a third here. Now that would be infinite. If we put a ... it'd be geometric because it's dividing by 3 or timesing by 1/3. And it is converging because they're getting smaller, and it's a series because we're adding them up. So that would be infinite geometric series that is converging. And that would have a sum. That's that a1 over 1 minus r formula. That's what you do there to find the sum in that case. But again, they're only if they're converging like that, getting closer to 0. Okay, so these are not the exact same quiz question, but these are just the concepts that were missed on the quiz. So the first one is this idea of a recursive formula. Okay, so most of this chapter is about explicit formulas, but we did cover some stuff in recursive. So pause the video and try this. If you have no idea, watch the first example and try the second. Okay, so explicit formulas calculate off of n. And for a geometric one, this is on your formula sheet, which I encourage you to have out. Maybe I'll show it on the screen here quick. But this is a geometric pattern. So make sure you have that formula sheet. So I'm going to do this formula right there. That is for a geometric geometric sequence. All right. So I'm going to do that formula. And again, that's an explicit formula. Okay. So all we got to do here is say what A1 is, which is just 500. And then R is a number we're multiplying by. So technically we're dividing by 5, but the R here is 1/5. And if you struggle with R again, you can take the second term and divide it by the first term. So 100 divided by 500, and that'll get you R. Okay, so there is our explicit formula, right? That would be explicit, but the recursive formula works a little different. So the recursive formula, you have two parts. You state what the first term is, which is just 500, and then when you do an, instead of using n like we do for an explicit formula, you use the previous term, which we call an minus 1. Okay, so on this one, it would be start with 500, and then to get the next one, you take the previous one, and then divide by 5 or multiply by 1/5. And I don't care how you write it there. If you want to write divide 5 or times 1/5, whatever is fine. Okay, so again, hopefully try the second one if you haven't already. Okay, so for recursive, this one's just adding by 2. So the recursive formula would say start at -20, that's A1, and then to get an the next term, take an minus 1 and just add 2, because you're just adding 2 each time in that pattern. Okay, and as far as the explicit formula goes, again, this would be arithmetic pattern, so it's A1 plus dn minus 1. That's the arithmetic explicit formula, where A1 is the -20, D is the 2, and so that would be the explicit formula right here. And again, you can clean that up if you want. You could distribute this in. I'm maybe not going to write it out too much there to save time, but I think it'd be -22 plus 2n is what it would be if you did the math there with the distributive property. Okay, next one. So again, trying to figure out which formula. They tell us here it's a sum and it's a finite arithmetic series. So I would look at your formula sheet first and see if you can find that formula. Okay, so the right formula here is we have Sn equals n over 2 A1 plus an. Sorry for the terrible handwriting there. All right, and again, pause the video and try this before continuing. Okay, so when we do our sum formula here, we know A1, the first term, is 3. We know the last term is 115. But the tricky part is we don't know how many terms. We know n goes 1, 2, 3, 4, but we don't know what is this 115. Is that the 20th term, the 100th term? We have no idea. Okay, so the trick here is you've got to use the explicit formula. Okay, so if you look up on the formula sheet, the arithmetic explicit formula is A1 plus D n minus 1 times. So we're going to write that, and then we're going to plug the 115 in here for the an. And we're going to try to find its position n. We are trying to find n, so we're going to plug in that an and then solve it for n. Okay, so writing out the formula real quick, A1 is 3, D is 2. And I'm going to clean it up this time because we're going to have to do that eventually anyways. So 2n, yeah. 2n minus 2, and then combine them. So 3 minus 2, so we'd have 1 plus 2n. And again, stick this 115 in as an. And we're going to solve it for its position n. So if we minus 1, we get 114. And then divide everything by 2, and I believe that should be 57. So that tells you this is the 57th number in the pattern. Okay, and that completes the formula because now we know there's 57 total numbers in the sum. And now it's just crunching away on the calculator. Add those together, it's 118. 57 divided by 2 would be 28.5. And now multiply those two numbers together, and our sum is 3,363. So that's the sum of these 57 terms in that pattern. Okay, so we had to use a sum formula, but oftentimes if you're missing a piece from a sum formula, you look up on the formula sheet and use the explicit formula. Okay, next big thing was just this big E notation. Okay, so again, I'm going to have you pause the video and try to make sense. It's finding the sum of the geometric series. So we know it's going to be the finite formula because there's only 10 terms. So there's our formula, 1 minus r. Sorry, that writing's so bad again. Okay, so I'm going to have you pause the video and try to make some sense of this before continuing. Okay, so you don't actually need to list them all out, but like what I really find will help here is what this E is really saying is you are summing spots 1 to 10 for this formula. Okay, so what I'm going to say is I'm going to list it as we do in a table normally, where n goes from 1 up to 10. Sorry, I don't know what's going on there. And then to find the actual numbers in the pattern, like the first number you can get by just putting 1 in there. So it's 3 times 2 to the 1 minus 1. And that actually just comes out as 3. And if you want to use your calculator there to confirm that, you can. But I'm going to go kind of fast here. So it's 3 times 2 to the 2 minus 1. So I think that's just 6. And then if you put a 3 up there, it's 3 times 3. No, 3 times 2 to the 3 minus 1 power. And I think that comes out as 12. Okay, so all of that is really to help me figure out that we're just timesing by 2. Okay, so as far as our formula goes, we don't actually need the 10th term here. We have everything we need to do our sum at this point, right? We know the first term is the 3. We know we're timesing by 2, so that's r. And then we know that there's 10 spots in our sum, so that's going to be right there. Okay, and then it's just a matter of, doing their calculator work from there. And again, I think I've talked about this in class, but I would do the denominator separately. Just do 1 minus 2, and then type the numerator into my calculator, and then divide by -1. Okay, so if we type that numerator in, we get this thing, divided by -1, we get 3069. So our sum there is little more than 3,000. Okay, and that's really what the big E means, means add up all those numbers for spots 1 to 10. Okay, this is going backwards. Okay, so we have a series here, and you got to imagine it goes for 10 terms. We want to write it in the big E. Okay, and then after that, actually find the sum. Okay, so again, pause the video and give this a shot. Okay, so the E really has 3 parts. It has the starting and ending position. So here it's for 10 terms, starting with spot 1. We can just assume that the 5 is in spot 1. So we're going to say we're just going to sum spots 1 to 10. Okay, and then here goes the explicit formula. Okay, so since this is an arithmetic pattern, our explicit formula is the A1 plus D n minus 1 times, where A1 is just the 5, D is the 4. And then normally they clean this up. So we're going to distribute this in 5 plus 4n minus 4. Make sure you multiply here before you'd ever add. And then 5 minus 4 is 1. Okay, and that completes our summation notation. Okay, and then if we actually wanted to find the sum is, this is an arithmetic pattern. So the sum here is n over 2 a1 plus an. And we know most of the things. We know there's 10 terms in our sum. We know the first term is 5. But the tricky part is we don't know the last term. We don't know the 10th spot. Okay, so we actually have to use this formula to figure out the 10th spot. So basically, if you want to know the 10th spot, just put in 10 for n. So we're just going to put in our 10 right there for n. And then if you crunch there, it's just going to be 40 plus 1 is 41. So that tells us that the 10th spot in our sum is 41. Okay, now we can complete our formula. So the sum, just do 10 divided by 2 is 5. Add those together to get 46. And then multiply those together, and I think it just comes out as 230. Okay, so that's the sum here is actually equal to 230. So that's what it looks like in summation notation, and that's the actual sum. All right, that's it. Thank you for watching.